for you with absolute value equations. These will be very similar to the ones that you will see in your Savas online assignment. So we will do some examples. Okay, the first example is absolute value of 2x equals 12. That means we're looking for what numbers are 12 units away from the zero. Remember that we said that whatever this quantity 2x is equal to, it might be 12 or it might be negative 12. So we split that equation into two, making one equal to a positive and one equal to a negative. Then we solve it. Divide both sides by 2. Divide both sides by 2. And there are your two solutions. You can plug them back in and check them if you want. 2 times 6 is 12. And 2 times negative 6. Now, when we plug it back in to check it, make sure you're plugging into the original equation and not to this one, okay? Not here, but here, when you're plugging in to check it. 2 times negative 6 is negative 12. The absolute value of negative 12 is positive 12. So both of those solutions work. What did we do? We split that equation and made it to one positive 12, one negative 12. Solve both sides, and then we checked them. Okay, let's try another one. Absolute value of negative 6x equals 30. The first thing we're going to do is split it. Negative 6x equals 30, and negative 6x equals negative 30. Because remember, we're looking for two numbers that are 30 units from 0. If you think about your number line, positive 30 is 30 units from 0, negative 30 is 30 units from 0. So we want that quantity of negative 6x to equal either 30 or negative 30. To solve it, divide both sides by negative 6. Divide both sides by negative 6. Remember that negative divided by negative is positive. And there are your two solutions. Okay, split it into two, solve it. You can check it. Remember, when you're checking, you're plugging into the original equation. So you have absolute value of negative 6 times negative 5. This is 30, right? So that one works. Check this one. Remember, plug it in here. Absolute value of negative 6 times 5. So that's negative 30. What is the absolute value of negative 30? It's positive 30. So that one works. Split it, solve it, check it. Next, absolute value of x minus 5 equals 12. We're talking about two numbers that could be 12 units away from 0. So whatever the x minus 5 is equal, it might be 12 or it might be negative 12. Solve this side. Solve this side. Let's check it. Take this 17, plug it into the original equation. That one works. Remember, plug into the original equation, not to the split part. Take this negative 7, plug it in for the x. Negative 7 minus 5 is negative 12. So those both work. Okay, what did we do? We split it, we solved it, and we checked it. And I dropped my paper that has all my problems on it that were working. Give me just a second. All right, I'm back. Now, next one is this one. Sometimes there's more steps. So we might have 3 times the absolute value of x, 3x minus 3, equals 27. The first thing you want to do here is to isolate the absolute value. What does the word isolate mean? During COVID-19, we've been very isolated. That means we have to stay in our house all by ourselves, right? We want to isolate the absolute value. That means we want to get these and whatever's inside them by itself. Okay, so first we have to get rid of this multiply by 3. How do we get rid of a multiply by 3? To get rid of multiply by 3, divide by 3. If I divide this side of the equal sign by 3, then I must divide this side of the equal sign by 3. These cancel. 27 divided by 3 is 9. Now I have a normal, well, an absolute value equation like we've seen in our previous examples. Okay, first step was isolate the absolute value. Second step is going to be to split. Remember, we make one positive and one negative. So I would have 3x minus 3 equals 9, and 3x minus 3 equals negative 9, because both of those numbers are 9 units from the 0. All right, let's solve this one. Add the 3, add the 3. 3x equals 12. Divide by 3. It's a 4. Okay. Solve the other side. Add the 3, add the 3. Negative 9 plus 3 is negative 6. Divide. So what did we do? We isolated the absolute value. We split the equation into 2. We solved both sides. We could check it. So take this 4 and plug it in here. Try to find enough room. 3 times absolute value. 3 times 4 minus 3 equals 27. This is 12, right? 12 minus 3 is 9. What's the absolute value of 9? 9 times 3, 27. What if I try negative 2? Three times negative 2 is negative 6. Minus 3 is negative 9. The absolute value of negative 9 is positive 9. Positive 9 times 3 is 27. So both of those work. So when you have other numbers there, then you would isolate the absolute value first, then split it, then solve it. Okay. Next, 6 times the absolute value of 4y minus 5 equals, oops, nope, not equals yet, minus 3 equals 45. What do we say our first step was? First step is to isolate the absolute value bars. So we need to get the absolute value bars all by themselves. So now I have 2 different numbers to get rid of. Okay, I need to get rid of the minus 3. We're going to get rid of the minus 3 first. By adding 3 to both sides. Is my absolute value isolated? Not yet. We still have that 6. This is a multiply by 6, so we get rid of that by dividing by 6. 48 divided by 6 is 8. So what did we do? We've isolated the absolute value by adding 3 divided by 6. Now we need to split it. Then solve it. Add 5. Ugly fraction. Add the 5. Negative 8 plus 5 is negative 3. Divide by 4. Ugly fraction. But that's okay. We could plug them in and check them and it would still work. Okay, you will see some like this on your assignment. Isolate the absolute value. Split it. Solve it. Okay, next. Absolute value of 5x minus 8 equals negative 8. So I'm looking for what two numbers have an absolute value, or what numbers are negative 8 units from 0 on the number line. Did that sound strange? I hope that sounded strange to you. Is it possible for numbers to be negative 8 units from 0? It's not. What did we say about absolute value? Absolute value is always positive. Think about your graph. We didn't have any negative numbers, did we? Okay, this absolute value can't be negative. It's this easy one. Absolute value can't equal negative. Now, if you have other numbers over there that are outside the absolute value, you have to get rid of them first. You have to isolate first. But if all you have is everything you have is inside the absolute value bar and it equals a negative, there's no solution because there's no way to have a negative distance from 0. Absolute value cannot equal a negative. No solution. Easy peasy. All right, I'm going to let you try. I'm going to write this one down, and then I want you to try it. Pause your video, try it, and then turn your video back on or play your video again and check it. Absolute value, x plus 2 plus 7 equals 30. Pause the video, try this problem, and turn it back on and see if you got it right. Welcome back. I hope you tried it and didn't just forward through. All right, so let's see, what are we going to do first? First step says isolate the absolute value. So what number is not in the absolute value? That's the plus 7. How do I get rid of plus 7? Minus 7. So now I have absolute value x plus 2 equals 23. Split it. Solve it. Is that what you got? I'm going to kind of solve it mentally. Take this 21 and plug it in for x. What's 21 plus 2? 23. What's the absolute value of 23? 23, you're right. Plus 7? 30. Let's try the other one. What about negative 25? What's negative 25 plus 2? It's negative 23. What's the absolute value of negative 23? 23 plus 7? 30. So that one works. Okay. What about this one? Absolute value of x minus 5 equals 3x plus 3. What's different about this one from our other examples? Do you notice there are two terms on the right side of the equal sign? So A little bit different, not too bad. Do I have to do anything to isolate the absolute value? No, it's already done. There's no numbers. There are no numbers on that side of the equal sign that are not in the absolute value. So I'm going to split it. X minus 5 equals 3x plus 3, and x minus 5 equals negative 3x plus 3. We want to apply that negative to the whole quantity 3x plus 3. So notice I put that in parentheses because that's going to apply to both of those terms. Okay? You can't just take the negative of the 3x. It has to be the negative of the whole thing. Okay, now when I solve that, I have x's on both sides. So I'm going to add 3x and add 3x. And then add the 5. And divide by the 4. Now, if you're working on Pearson, we know that we could type this as 1/2 or we could do 0.5. It means the same thing. Be very careful in your, I said Pearson, Savas. Savas and Pearson, same thing. When you work on your online assignment, be very careful and read the blue letters in the instructions for each problem because it will tell you how to type the answer in. And if it says use a fraction and you type a decimal, it's going to count it wrong. You must pay attention and type it like it says. All right, so one of our answers is 1/2. If I solve this side to get all the x's on one side, I'm going to subtract 3x and subtract 3x. And this is negative 2x minus 5 equals 3 because those cancel out. This is going to add the 5, so you have negative 2x equals 8. Divide by negative 2. There are your solutions. You can plug them back in and check them if you want. What do? We split it. Make sure if you have more than one term over here that you use parentheses and distribute your negative. Okay. I think we already did this one. Hold on. Let me look. Yeah, we already did that one. That's my last one. All right. Questions? Email me, mrodell@robinson.k12.tx.us. Have a wonderful day.